To continue on learning about triangles, today we're going to work with the angle relationships in a triangle. So our goal is to find the measure of interior and exterior angles of triangles and also to apply theorems about the interior and exterior angle of triangles. So the words that we're going to need to learn for today, auxiliary line, corollary, interior and exterior, those angles, and also remote interior angles. So, the first thing we're going to learn is something I'm sure you already know, that the sum of the angle measures in a triangle is 180. So pretty much we're giving that fact a name. That is the triangle sum theorem. So think if you ever needed to use that in a proof, your reason would be triangle sum theorem. When we use that theorem, sometimes we use what's called an auxiliary line, or just a line that we add to a picture to help us in that problem. So in this picture you see line L I could draw in, and that's an auxiliary line. So if I took a triangle, just picture this, if I took this triangle and I ripped apart the angles, so I ripped this angle off, I could move it and it would fit right into where angle 4 is. Notice if these are parallel, alternate interiors, those are congruent. So if 1 and 4 are the same, if I ripped this angle off and put it in for 5, 3 and 5 are the same. So the three angles in a triangle would all add up to make a straight line, which is why they all add up to 180 degrees. So let's look at an example using that fact. This just puts it in a little scenario. After an accident, the positions of cars are measured by law enforcement to investigate the collision. So we're going to use this picture and draw some conclusions from what we see. So first we want to find x, y, z. So if I look at this angle right here, I see that part of a triangle that I already know two angles to. So in this big triangle, if I were to add up x, y, z, y, z, x, and z, x, y, I know that they should add up to 180 degrees. And how I knew that was the triangle sum theorem. Now if I look at the angles that I know, and I substitute 62 and 40 in for those measures, and then I simplify, I'll add those two numbers together. I know that I can find the measure I'm looking for, x, y, z, by subtracting 102 from both sides. And I see that this angle right here is 78 degrees. Okay, now we're going to look at the same picture, but we're going to look for angle YWZ. So this little corner over here. Notice that that's a part of this smaller triangle, as well as part of the big triangle, so we could really use either one. But if I look at this little triangle, I know I need this left angle. I don't know the right angle, but I do know the top angle is 12. So if I can figure out what this bottom angle is, that can help us find the third angle. So before we start, let's see if we can figure out what the measure of WXY is, the second angle in the triangle. Well, I see that WXY and YXZ, do you see that those two angles make a straight line? So I know that this angle plus this angle should give me 180 degrees, and that's because they're a linear pair and we're using angle addition, part plus part equals whole. So if I look at that equation and I plug in measures that I do know, I know that YXZ is 62. So I can plug that in. Now to get this angle, I'll subtract 62 from both sides. And I see that this bigger angle is 118. So that one right there, 118. So now if I look at the whole triangle, this little guy, I have one angle that's 12. I have one angle that's 118. So now we can find the angle we need by adding up the three angles in the triangle and setting them equal to 180, because that's what the triangle sum theorem says. If I plug in the two measures that I know, I need this one, but I know 118 and I know 12. So if I simplify that, I get that the angle plus 130 gives me 180, so I'm going to subtract 130 from both sides, and I get that we have w or ywx to be 50. Notice that the question asks for ywz. Notice that that angle and w or ywx are the same angle because x and z are on the same line. So you can name it either way, but they're really the same angle. Now, along with our postulates and our theorems, we also have what are called corollaries, which is a theorem whose proof follows directly from another proof. But they're treated all the same, just as statements that we are going to use to prove things or to find certain information. So two things that we're going to learn about triangles is that the acute angles of a right triangle are complementary. Well, that makes sense if all three add up to 180 and a right triangle has one angle that's 90. If I take that out of the sum, I know that I have 90 degrees left for these two. So anytime you have a right triangle, you should see that the two acute angles should be complementary or add up to 180 or 90 degrees. The next one says that the measure of each angle of an equiangular triangle is 60. So remember that equiangular means that the three angles in a triangle are congruent. Well, if the measure of the angles in a triangle add up to 180 and these are all the same, 180 divided by 3 gives us 60. So that's why we can say that. Alright, so some examples that go along with that. One of the acute angles in a right triangle measures 2x. What is the measure of the other acute triangle, or acute angle? So let's say we have two angles. We're just going to give them names by plugging, or we'll call one A and one B. So the first one we'll say is the one that has the measure of 2x. Well, I know that if they are two angles of a right triangle, they should add up to equal 90. We said they'd be complementary. So now, if I substitute the measure that I have in for x, it looked like this. So to find the other acute angle, I'm going to subtract 2x from both sides. And this is one of those problems where I don't know what x is, but I can give a better representation about what the answer is. So the measure of angle B, even though I don't know it specifically, we're going to call 90 minus 2x. Here's another one using a decimal. If one of the angles one of the acute angles in a right triangle is 63.7, what's the measure of the other two angles? So we've got two angles, A and B. One of them 63.7, but the two added together equal 90 degrees because acute angles of a right triangle are complementary. So I'm going to plug in 63.7 for one of the angles, and now if I'm trying to get the other angle by itself, I want to subtract 63.7 from both sides, and I get that the other acute angle would be 26.3. So now we're going to look at different parts of a triangle. When we look at a triangle, it has an interior and an exterior, just like our two lines when we had transversals. Anything inside the two lines is considered the interior. Anything outside the two lines is considered the exterior. So if you were trying to label a point in regards to the triangle, you'd have to see, is it inside or is it outside? So that was our exterior. Now we have what are called interior and exterior angles. Interior angles are formed by two sides of a triangle. And so if I took two sides of the triangle, I see that it creates angle 2. But it's an angle on the inside of the triangle. But an exterior angle is different. It is formed by one side of the triangle and the extension of an adjacent side. So what it's saying is if I want an exterior angle, I'm going to use one side of the triangle. I'm going to draw the other side it's close to, farther out, creating a line that wasn't there before, like an auxiliary line. And the exterior angle will be the angle right there. So in this picture, notice we have 4 angles. We have 1, 2, and 3 on the interior, and angle 4 is on the exterior, or the outside of the triangle. Exterior angles have 2 remote interior angles. The way I think of remote interiors if I'm sitting at 4, if there's like, say, a chair here or a couch, and I wanted to look at my other TVs, maybe it's where 1 and 2 are, I'm too lazy. I'm not going to get up and I'm not going to walk over and touch the TV to turn it on. So I use my remote. So a remote you don't need when you're sitting close to something. So remember that a remote angle, whether it be interior or exterior, is considered farther away. It's kind of got a distance between the two things. So a remote interior angle, notice it's farther away. It's not right next to. It's farther away and it's inside. So in this picture, if angle 4 is our exterior, you're going to call angle 1, and angle 2 your remote interiors. So when we have when we have exterior angles, we have a theorem that goes along with it. The exterior angle theorem says that the measure of an exterior angle is always equal to the sum of the measure of the remote interiors. So if I want this angle on the outside, I can also say that it's equal to 2 plus 1. Notice, like I said earlier, if I were to rip these corners off, 3 would stay the same. I would fill in this section with number 2, and then the rest would be filled in with number 1. So those should always add up to 180. So with 4 being the same size as 1 and 2 together, these remote interiors will add up to give you your exterior. So an example of this, we'll jump right into it with some variables. If I'm finding the measure of angle B, notice I got to figure out a measure for x first. Well, they give me BCD, they give me B, and they give me A. So what we talked about before is that the remote interior, so if I'm sitting in my exterior angle and I'm hitting my remote to get to the outside angles, I have A plus B gives me BCD. Now I'm going to take the measures they gave me for those angles and I'm going to plug them in. So angle A is 15 plus angle B, 2x plus 3 should be the same as 5x minus 6. So we're going to simplify or combine like terms on both sides. And then on the equation I see that the 2x is smaller than the 5x, so I'm going to subtract 2x, and then I'm going to divide by 3. And my x is 26. Good. Now, if I want to figure out the measure of angle B, and they said it's 2x plus 6, well, x is no longer missing. I just found out it was 22. So 2 times 22 plus 3 will give us 55. Okay, here's another one. In this one, we want to find ACD. So we want the measure of the exterior angle. So this exterior angle, remember we learned, should be equal to whatever the sum of our two remote interiors are. So angle A plus angle B should also give me the measure of ACD. So after I've set up the equation, I'm going to take the measures that I know, I'm going to plug them in. So since it says ACD is 6z minus 9, I'm going to put that there. Angle A is 2z plus 1, and angle B is 90. So if I plug those in, the next thing I want to do is simplify. So I'm going to combine my like terms, 1 and 90. And then I'm going to look at my z's first, and take the smaller one and subtract from both sides. And then to get z, I'm going to divide both sides by 4. So I get that z is 25. But I always want to make sure I go back and look at the problem. It wanted ACD, so I'm going to plug 25 in for z, and 6 times 25 minus 9 gives me 141 degrees. The last thing we want to learn about is the third angle theorem, which says that if two angles of one triangle are congruent to two angles of another, then we know that their third angle must be congruent. So notice L and R are congruent, S and M are congruent, so the theorem says that means N and T must be congruent. So we don't really have time to look through this example, but I'll show it to you real quick and you can click through it later. If I want to find the third angle, it shows me two sets are congruent, so I know these sets have to be congruent because of that theorem. Because the angles are congruent, that means they're equal. If I substitute those measures in, and we can solve, And that's where we'd get.